Welcome back, everyone.
That's on, right? That's on.
Yeah.
No, it's only one mic.
Test,
Turn it
test.
off real quick.
Oh.
Hold on.
Check. We will need batteries in this eventually. Our next team project presentation today is officially titled Monitoring the Environmental Effects of Hydraulic Fracturing Using Remote Sensing. We've chosen to shorten that, and I'd like to introduce team project Tracking Fracking.
One project.
9 weeks,
30 participants,
7 departments,
16 countries,
14 languages,
2 co-chairs,
1 teaching associate,
34 TP meetings,
International.
interdisciplinary,
intercultural,
hydraulic fracturing,
fracking,
remote sensing,
Spectrometer.
airborne,
methane, air pollution,
emissions,
greenhouse gases,
energy, technology,
shale gas,
monitoring,
pollutants,
wills,
Ohio.
essence, team project plan,
executive summary, final report.
internal review, final presentation,
NASA,
International Space University,
Ohio University,
Space Studies Program 2015.
Increase the awesome.
increase the awesome,
increase the awesome,
Increase the awesome.
Good morning, Athens. I'm Kate Kreiderman. Welcome to Space to Earth, live from ISU TV, where we focus on space applications for the benefit of Earth. Today we're going to talk about hydraulic fracturing, or fracking, which is highly controversial not only in America, but all over the world. Today we're going to focus on the most relevant aspects of fracking, including the context in which fracking exists, the economic impacts, and why there's a need for more information to provide to the stakeholders to make informed decisions. The stakeholders include you and me, the public sector, such as local and state governments, and the private sector, such as oil and gas companies. So today we're going to have lots of guests on the show, including scientists, experts, and even a PhD student, here to talk about fracking, what the problem is, and why space is part of the solution. So thanks for watching, and let's get started. So the first guest on the show today is Dave. Welcome to the show, Dave.
Thank you.
So Dave is an expert on the process of fracking. So can you take a couple minutes to explain to us what fracking is?
Sure. So fracking itself is a process of extracting unconventional resources, natural gas primarily, that's in some really hard to get to areas of shale, and it's really split up. And so to start off the process, a company has to decide where they want to frack and then to acquire the rights to the land, the mineral rights. Once they've done this, they're going to come in and they have to clear off a piece of land and get started. So the trucks will come in, they'll clear off 1 to 5 acres, and they'll cement off a pad. They'll put up containment around it to keep from spills and contamination of the environment around it from surface water and runoff. And then once the pad's prepared, they're going to bring in the water and the trucks to actually do the process. So this can take up to 1,200 truckloads, millions of gallons of water, and then some frac pumps and drilling equipment and all that. So the process starts, they'll actually start drilling the well. They drill down through the water table, and once they've gotten through the water table, they put a steel casing in, and then they'll put cement around it, and they'll do multiple layers of this, and this protects the water table from any leakage through the sides and keeping the groundwater sources clean. Once this is completed, they start drilling downward. They drill down up to 10,000 or possibly more feet.
So this all sounds like a traditional well. How is fracking any different?
So this is where the new technology comes in. They have what's called the kick point. This is in the bottom corner here of this diagram. And that's where the new drilling technology allows them to turn the drill head sideways and drill horizontally or up to an angle to follow the shale layer. The shale layer can be as thin as 50 meters thick in some sections, so 10,000 feet underground and only 50 meters thick. So once they come across, they drill up to 6,000 feet across, and then it's time for the fun stuff to happen. So they're going to case this out with a steel tube and cement that as well to prevent any leaks into the surrounding rocks and structures. Now they're going to insert some explosive charges in here, and they're going to set them off at these points here, and that actually determines where the cracks will propagate from. Once these are done, they're going to inject high-pressure water containing some chemicals and some proppant, sand primarily. And so what happens is the high-pressure water expands these cracks, and it allows the actual natural gas resources to flow back into the well. The sand actually goes in and props open this so that when the pressure is released, there's still a pathway for the natural gas to come out of. So then the water flows to the surface. Once the water flows back out, the natural gas starts producing. And then the water itself, those millions of gallons that we had talked about earlier, a lot of it's taken to other wells to be reused. Some of it's actually cleaned and decontaminated, which is a new research field. And then a lot of it is injected into Class 2 injection wells, where they'll inject it underground, where it will be permanently stored.
From the way you've described it, it all sounds safe. So why do environmentalists disagree with this so much?
So if everything is done according to the rules and regulations, it's actually a very safe process.
Hey, hold on. Ooh. It's not safe. I know the reality. Hello, I am environmentalist. Can I share my views? Hello, sir. Can I have mic, please?
We'd like to hear what you have to say.
Yeah?
Yeah?
Hello, everyone. I am working in Ohio for last 5 years. I know the reality. Mr. Dave says fracking is environmentally safe. This is not true. Fracking has serious negative environmental effects. It causes polluted air, contaminated soil and water, and even causing earthquakes. The toxic air pollutants are released at each and every stage of fracking process, not only from the fracking well, but also from all the surrounding infrastructure, the tanks, the dehydrators, the pipelines, the diesel trucks, all emit air pollutants. The methane, which is released during this process, is a greenhouse gas, and it is accelerating global warming. The VOx, NOx, and gases, they lead to the formation of tropospheric ozone and acid rains, and that is harmful to our health and environment. The fracking fluid contains many known carcinogens and toxins, and even radioactive elements. The leaks from the fracking sites contaminates our surface and groundwater resources. And the fracking fluids, it also having a very high concentration of methanes. It has been found that the areas having fracking, having 17 times more methane than the normal well.
Okay, sir, I'm sorry. I'm going to have to interrupt you there. But thank you so much for speaking up. We only have limited time on the show. But thank you.
Okay.
Thank you very much. I think here on Earth to Space, we like to hear all sides of the story. So thanks to you and thanks to Dave for being here and explaining the stages. I think we better understand now the environmental impacts associated with fracking. So we're going to take a short commercial break, and when we come back, we'll be joined by a businessman who's been impacted by fracking.
Energy, a primary need for each country. As a country grows, its energy need increases more and more. Hydraulic fracturing provides the country and the people a bridge to energy independence and new job creation, using the highest standards for regulation regarding environmental protection, providing a better future for America and its sons. Fracking, because we care. I'm John Wayne, and I approve this message.
Welcome back to the show. I'd like to welcome Marius.
Hi, Ms. Kruiderman. I'm here to talk about the perspective of fracking from the automotive.
Yes, Marius is a CEO of USA Automotive. So as a representative of a company that produces automobiles, can you explain to us how fracking has impacted your business?
Yes, it's interesting. Have you heard of the EPA regulation CAFE?
Mm-hmm.
Yeah, this stands for Corporate Average Fuel Economy. And that, in addition to loads of others of EPA regulations that are meant to reduce the amount of air pollution in cities, they impose regulation on us. Our cars obviously emit some chemicals, so like we have to reduce our emissions. So the CAFE, these other regulations, all of this stuff, they make life hard for us, really. But, Ms. Kruiderman, are you a car person?
Sort of.
Ah,
I have a car.
person. Big applause for car person, Kruiderman. So, Ms. Kruiderman, come on. You know, when you have a car, have you ever taken a look under the hood?
Many times.
Yes. So, have you noticed the PCV valve, the EGR valve, the variable valve timer, the oxygen sensor?
Ooh, this is a lot of car lingo. How do you connect this back to fracking?
Well, as I said, we have to reduce our emissions.
Mm-hmm.
And the thing about hydraulic fracturing is that they emit many of the same chemicals as we do. Whereas we know how much chemicals we do emit, they haven't gotten a clue, those frackers. And so we have to, that puts the entire burden of reducing the emissions on us as an industry. Whereas they can go on drilling, and we have to develop new technology. So it makes life hard for us.
So what do you see for the future of your industry?
The future? Well, the thing about fracking is that they have brought us cheap energy. Cheap, we have been like, America's become energy independent, woo! Mm-hmm. And the thing, the more cheap energy you get, the more people can drive, because gas gets more cheaper. So that's a good thing for us. More people drive, the more new cars we need. The more cars we sell, the more happy we are. But on the other hand, the regulations imposed on us require us to continuing to struggle to develop new technology, spend lots of money, and we take a burden for something that isn't completely our fault.
I understand pros and cons. I think we better understand how fracking impacts other businesses. So thank you so much for being here today.
Nice to be here.
Thank you. Okay, we're now going to go to our field reporter to get some opinions from some young adults out in the community about their opinions on fracking.
Honestly, I've heard a lot about it in the news. You see a lot of protests from time to time, but I don't know too much about the science behind it. I know what it is and how they do it, and I know there is a controversy behind the environmental damages that fracking has.
From a scientific point of view, it's simply a technique they have for accessing oil and gas under the ground that is relatively new, at least as far as being able to do it economically.
It's kind of one of those things where it doesn't affect you out of sight, out of mind. But at the back of my, but then again, in the back of my mind, I do realize that it could potentially affect me in the future.
I think there's enough research that shows that it can cause unrecoverable damage to our environment. It used to be very pleasant and rural, and it's not now.
Ugly and barren,
and the trucks just are up and down.
I think it has the potential to have more pros than cons. I feel like they need to work on it a little bit more and be a little bit more transparent as well.
It's very complicated because on one hand, my family has a farm. It's been in our family for about 150 years. And do not own the mineral rights to part of it. So it could be fracked without our permission. We do own the mineral rights to another part of it, and my family has leased the mineral rights. So on one hand, my parents are essentially living on money from fracking.
Seeing the short-term benefits of fracking has really done the same with me, where it's like put off the downsides of it, and it's really focusing more on the good. And so I think that until we see a very large impact on the downsides of fracking, that there won't be any changes to what's going on.
It's not something that is sustainable.
People are going to do what's cheapest and gives them the most profit after the fact, right? So until we put research money into alternative energy to make, alternative energies cheaper than natural gas and more profitable than natural gas or oil, nothing's going to change. It's just going to get worse, and we're going to hurt the environment more, and we're going to exhaust these resources even more.
I'm very glad that you're investigating this.
Okay. Now that we've heard from some young adults in the community, let's hear from some professionals who are more involved in the fracking industry to ensure we're hearing all sides of the story.
I'll start by saying I'm really glad it's not in Athens County yet.
My opinion mainly is that it has been sold as a bridge fuel to people, and I believe that it's actually more like a procrastination fuel. In other words, it helps not to deal with a transformation that we really need to do, and that is moving away from fossil fuels.
My personal opinion on fracking is that the industry is moving a lot faster than the regulations and the science, and so I feel like in some ways we're kind of putting the cart before the horse, where we're rushing to put in a lot of infrastructure without necessarily putting in the regulatory safeguards that are going to make it a long-term safe industry for Appalachia. Do I think that there are huge, massive problems with every well? No. Do I think there are impacts from every well? Yeah.
There are a couple of issues that are particularly important. One is the pollution due to escaping methane, which is a real problem. You may be acquainted with the NOAA data, for instance.
So all things considered, I think it's very much a positive. It's resulted in actually, depending how you look at it, it certainly resulted in natural gas prices being as low or lower than what they were 10, 12, 13 years ago.
Banking positives against negatives, the equation for me tilts to the negatives much more heavily than it tilts to the positives. I wouldn't pretend that there aren't positives though. I mean, I have colleagues who'll say, this is horrible, and there have been, that's not true. There have been jobs created. There have been opportunities for landowners to get wealth in a region where the value of your signing bonus is higher than the value of your farm. So that's the underlying political economy that we have to pay attention to. Why did people sign up and lease? Right? Because they're bloody poor. I mean, this is the reality of the region.
Energy independence does not come from an extractable resource. It's not renewable. It's not sustainable.
I think that I would probably make 2 points: that we have to have serious regulations on waste handling. And the other piece would be lobbying for tax code changes to enact a severance tax and make the tax code such that money actually makes it to the communities that are being impacted.
If shale up and walked away tomorrow, the poverty rate in this region wouldn't change. Chances are if shale up and walks away in 10 years, the poverty rate won't be different. That to me is a problem. And if we're left with a more degraded environment, fewer places where we can grow food, more people have left because they had those jobs and then those jobs moved and they left, then it won't in the words of my business friends, it won't cash flow out at all.
Okay, so now we've heard from a variety of opinions in the community. So I'd like to move on to our next segment, which is our daily newspaper review. So I invite Matt, I don't know who Mike is, up to the stage. Welcome to the show, Matt.
Thank you. It's a pleasure to join you this morning.
So Matt is a journalist at the Athens Daily Gazette. He's worked in Ohio covering the news for over 15 years. And today he's going to share some recent newspaper headlines with us regarding hydraulic fracturing. So take it away.
Thank you. Hydraulic fracturing and its effects, both proven and perceived, have been in the news a lot, not just recently, but several years now. Estimating and quantifying methane emissions in particular has been a hot topic of study. Unfortunately, the conclusions of all those studies tend to contradict each other. There's no real solid estimate of methane emissions out there, and one example has come to light this week. In 2014, so just last year, a study was published by the University of Texas where their data led them to conclude that methane emissions, in particular from hydraulic fracturing, were inconsequential. Unfortunately, depending on how you look at it, just this week, in fact, on Tuesday, the New York Times and a number of other news organizations have reported on a new study published in the journal Energy, Science, and Technology, which completely refutes those findings. There are a number of known limitations with and errors with the instrument that the group at the University of Texas used, and those were not accounted for. Those errors would tend to bias their data low, which could be, and indeed was demonstrated to be, the cause of their low findings and their conclusions. So unfortunately, this leaves us right back to where we started, where we really don't have a good understanding of just what the emissions from fracking might be. Also this week was another headline here in the US, which is going to force us to really understand and quantify these emissions in a much more concrete fashion. President Obama unveiled a plan to tighten greenhouse gas emission restrictions by 2030. Basically, each state in the US will be required to cut greenhouse gas emissions by 32% relative to 2005 levels. That's a challenge any way you look at it, arguably made more difficult by the fact that as fracking becomes more common and the methane emissions from that also become a greater proportion of the greenhouse gases that are emitted, as a result of methane's significantly higher potency as a greenhouse gas, that adds a new complexity to monitoring and managing those emissions. So clearly, if hydraulic fracturing is to continue here in the US and elsewhere for that matter, we will need a clear and cost-effective way to monitor and regulate those emissions. Of course, this is being in the U.S., a journalist here in the U.S., this is, thus far I've focused on the U.S., but this is an issue around the globe as well. This technique is employed in other countries, the UK, China, for example. And I believe I've brought with me a clip from a Chinese news agency I'd like to share with you now, if you don't mind.
Please do.
各位观众好，欢迎收看中国空间新闻。近年来，随着美国页岩气革命的成功，在全球引起开发热潮，页岩气有可能正在重塑全球能源格局。中国作为能源消费大国，对进口能源的依赖非常严重，在能源消耗中，煤的使用比例很高，成为造成环境污染的重要因素。作为页岩气储量大国，中国页岩气的开发有可能有助于提高能源安全，应对气候变化和解决过度依赖煤炭造成的空气污染问题。中国已将页岩气开发确定为重要发展方向， 国家能源局将2020年页岩气产量规划为300亿立方米，目前正处于页岩气发展的初级阶段。页岩气的开发还面临诸多挑战。首先，页岩气开发技术和经验尚不成熟，页岩气产区地质条件复杂，埋藏深度较深，增加了钻井的成本，对开发技术也提出更高要求。其次，页岩气开采采用水力压裂技术，需要大量的水。中国的页岩气产区主要分布在西北、西南等水资源缺乏的地区，大规模开发页岩气将可能加大当地水资源缺口。此外，页岩气开发将可能带来空气、水和土壤等多方面的污染，导致严重的环境问题。因此，中国页岩气开采还有很长的路要走。中国空间新闻网 Coco 来自北京的报道。
I've reported on in the U.S. are reflected in China as well, and the same is true across the globe. I think that speaks to the emphasis that necessary for an effective monitoring solution that we need to get started on immediately.
Very much so. Thank you for joining us today, bringing us these timely news articles from around the world.
Thank you.
Thank you. Okay, after the commercial break, we'll be back with an SSP talk. Corey will be discussing how we can monitor the atmospheric effects of hydraulic fracturing. And for those of you who don't know, an SSP talk is similar to a TED talk, but it really increases the awesome, so don't go away.
Have you ever heard about fracking? Have you ever heard about its impact on our environment? Are you really sure lobbyists and oil companies told you all the truth? Because of fracking, earthquakes are increasing. The water is getting polluted. The air is getting polluted. Our environment is getting polluted. Is this really the world we want to leave to our children? Is this really the way our planet deserves to be treated? I don't think so. If you care about our future, stand up against fracking. Now, before it's too late. I am the president of Green Ohio, and I approve this message.
Good morning, everyone. My name's Corey Newman, and I'm here to talk to you today about something really, really exciting. Up until now, and this morning, you've heard all about hydraulic fracturing, and you've heard all about the environmental effects hydraulic fracturing has. However, no one yet has talked about monitoring these effects. This is what I'm going to discuss with you now. In scholarly articles, when you search on the internet or in the library, all the information that comes up is about monitoring the effects on the ground and with water. There isn't that much information on monitoring the effects of air pollution on hydraulic fracturing. When we want to monitor the effects of air pollution, we have 3 different platforms with which we can use. The first platform, and the most important platform, is space. Using space and satellite applications to monitor the effects of hydraulic fracturing gives us a wide coverage area and view of what happens to our air and the atmosphere. When we use satellites, we can use them globally. However, this is an example of a satellite image, which I'm sure you all know about. As you can see, this is a demonstration purpose only, so it's shown in the visual range. When we talk about monitoring the effects of air pollution, most of the time we're not using visual images, but images in other spectrums. So as you can see from a satellite image, everything looks clear from space. However, when we zoom into the resolution that we want to monitor, we get something that looks like this. This is a very pixelated image of data that we would get from a satellite. And unfortunately, with today's technology, this is unusable for what we want to do. The second method that we can use is the air. And when I talk about air, I'm talking about mounting a sensor on a plane or a UAV, which can then be flown over areas to monitor the air pollution in that area. The advantage of using the air is that we get an image that's slightly further in and slightly higher resolution. And in this case, you can see Ohio and the area we are today. Unfortunately, to do this, it requires a lot of time and a lot of effort, and unless we know where we want to fly the aircraft, again, it's pretty useless in our application with what we want to do. The third method we can use is ground-based monitoring. Ground-based monitoring is where we send a mobile truck or a sensor on different sites on the ground. We can take a canister of air, and we can go and then analyze that air in the laboratory, which gives us exact chemical composition of that air. The disadvantages of this, however, are, one, that it's extremely expensive to do on many different locations, and two, we're only capturing 1 point in time along with 1 point on the Earth. When we have an area that looks like this, it's extremely unrealistic to install ground-based monitoring at every different station, and it's extremely expensive. So now on to the exciting part. The exciting part is that we do have a solution. And our solution is that we can use all of these combined to get the data we want. If we use our satellites to look at our broad area, and we can focus in on the area that we want to monitor, we can then use aircraft or UAVs to go and fly around that specific area, again, focusing in more. And then we can also, once we focus in more, go and use our ground-based sensors to go and clarify our picture even further. All of this data will be inputted into a GIS system, which we can then share to educational institutions, to the industry, and most of all, to governments. We end up getting something that looks like this, a clear image of what we want to do. So by using our proposed methodology, this is the only way we have with today's current technology to monitor the effects of air pollution and hydraulic fracturing. Thank you.
Thank you, Corey. That really was awesome. I think we understand now why we currently have to use a multi-platform solution to monitor the atmospheric effects from fracking. So now I'm excited for this next segment. Last week I was invited by Ohio University and International Space University students to go flying over some hydraulic fracturing sites while they conduct an airborne experiment. So we have some footage, and let's take a look. Hi, my name is Kate. I'm here at the Ohio University Airport with the International Space University. They've invited me along to go flying over some hydraulic fracturing sites. Let's get going.
Ohio University traffic, Cessna 345 Alpha Romeo is taxiing onto position, runway 25 for takeoff.
So we have arrived at our data collection location in eastern Ohio, flying over some hydraulic fracturing sites. Here on the map. The students in the Space Studies program are about to start collecting data from the sensor.
So if I can have Annie and Fabio join us out here. Welcome, guys. Hi, Fabio.
Hi.
Hi, Annie. So Fabio's from International Space University, and Annie's from Ohio University. So thanks for taking me flying last week. Can you explain to the audience what your experiment entailed?
Sure. So as part of our proposal and after caref analysis, we decided to fly a spectrometer. A spectrometer essentially is this instrument that measures the amount of light that's absorbed or reflected by different compounds in different wavelengths. So with this technology, we're able to study the atmospheric conditions around the fracking areas. It is the very same principle that scientists use to determine the chemical composition of stars and planets far away. So methane has a light absorption signature at 1665 nanometers. This is near infrared. We don't see it. This is above the visual portion of the spectrum. But our sensor does. So our sensor is specifically designed for this application, and it measures everything between 1610 to 1680 nanometers. So our first experiment was to point the sensor to a plastic bag full of natural gas, which is at least 75% methane, and to another plastic bag full of regular air. So once we learned how to operate the sensor and to calibrate the sensor, we pointed the sensor to a real leak from a real natural gas pipeline, the picture on the left. So the next step would be to mount it on a plane, pointing down, do some basic math to determine the optimal height and speed of flight. But this is something that Annie can talk more about.
Sure. Well, first of all, I just want to say that this project would not have been possible without the support from the Avionics Center at Ohio University. Mounting a sensor on a plane is not an easy task. To cut a hole in the aircraft, to put the sensor in, getting the aircraft prepared on a very short timeline is not easy, and they were able to do that for us on a very short timeline. So that's really fantastic, and we really like to thank them for that. So for the flight plan itself, we picked a dense area of fracking activities just northeast of Ohio. We selected this area based on a recon flight that we did previously. Also satellite data and satellite imagery help us kind of locate these areas, and also online databases allowed us to get more information on the status of each site. So for the flight itself, we flew at an altitude of 1,000 feet and a speed of 100 knots, which is about 50 meters per second. During the flight, we collected the sensor data and also collected GPS information using a laptop. We also mounted a camera right next to the sensor and was able to collect some really great aerial footage, as you can see here. Our next step would be to kind of overlay our data on top of this footage and kind of see what the sensor is seeing at the time. So during our data analysis, we were able to find some absorption peaks along our tracks, and this is really exciting for our first test flight ever, and the first time this type of data has ever been collected in Ohio. So that's really exciting. And our next step for us here at Ohio University would be to collect more data, perform ground tests with known concentrations of methane to really understand the sensitivity of the sensor, as well as flying over known sources of methane and compare that with our aerial results to really understand how it all works. And finally, I just want to say it's been great working with Fabio and the International Space University. This project has been an amazing catalyst in starting this research here in Ohio, the first time ever in this state. And we really look forward to using this sensor to continue this project.
Wow, it's really impressive what you've been able to accomplish in such a short amount of time and such an exciting step forward. So thank you for being here. And Annie, I think we'll see you a little later. Thank you. Thank you. Okay, so now that we have seen how data can be collected, I want to bring out two more guests who've been working on integrating this data from the 3 different platforms, ground, air, and space, into a useful visualization tool. So Adam and Dr. Himanshu, can you join us, please? Welcome. Welcome. So Adam is a PhD student working on this visualization tool, and Dr. Himanshu is looking at the future of remote sensing. So Adam, to kick things off, relative to other US sources, how significant are methane emissions from fracking?
Well, they're extremely significant. If you look at all the man-made sources of methane in the US, oil and gas production is by far the greatest source, and there's strong evidence to show that fracking sites compared to conventional oil well or oil and gas well sites are even greater emitters of methane, sometimes hundreds of times, depending on the region where you make the measurement. So it's a very big issue.
And I know you've created this visualization tool that integrates data from the ground, air, and space. Can you explain this to us?
Sure. So this is the demo that we created, a group of us together, and under Dr. Himanshu, of course. And what it shows is that it's really quite possible to put together a basic data platform, a GIS platform that puts together all the data that, or some of the data that people would be interested in seeing. So an average person, if they look at a data set, they don't have the training or the time to go and understand it. But in our lab, we have that training, we have that time, so we created this. And what it shows is you have data points that are of interest at the bottom, like on the legend, and you can see those points on the map and you can click on them. We chose to display very limited data because it's just a demo, but we can display all kinds of data about any point, concentrations, positions, time of measurement, things like that. So if you're like our stakeholder, a person or a agency or even a company, you want to see what's around you, it's a very easy way for you to do that.
Thank you. This is amazing. Can you elaborate a little bit more on how this can benefit our stakeholders, like local governments, environmental agencies?
Sure. So as I said, average person doesn't have the time to understand this. So for the fracking, for the people of Ohio to give their mandate, and also the people of the world to give the mandate to their governments to continue fracking, they have to be able to understand what the effects are. And right now, especially in terms of air, that's not really possible. So this is the first step on Dr. Himanshu's roadmap of showing people what's going on and allowing them to make decisions and push those decisions to their representatives.
Thanks, Adam. That was a great segue. Dr. Himanshu, I know you've worked very closely with Adam. Can you explain how you envision the future of this project that you're working on?
Yeah, I think the future of remote sensing is awesome. In fact, we have created one roadmap for implementation of remote sensing system for monitoring of hydraulic fracturing. The roadmap is divided in 3 sections. The first is a short-term plan, second is a medium-term plan, and a long-term plan. So let's look at the roadmap. So first is the short-term plan. The short-term plan is basically for up to the next 2 years, like what is possible in next 2 years. So the short-term plan is based on the existing technology and today's available resources. And the solution is multi-platform. Like we will be using the sensors from the spaceborne system, airborne system, and ground system. And there will be a data fusion algorithm. So we will combine data from space, from air, and ground, and we will generate one data product, and which will be distributed to all stakeholders. The stakeholders are like the government agencies, the public, the industry, and environment protection agency, etc. So we'll be using the satellites which are today operational in the orbit and the satellites which are going to be operational in the next 2 years. So this solution is the solution which can be immediately we can implement on any state. Next is the medium-term plan. The medium-term plan is from 2 years to 10 years. So this is basically augmentation of our existing solution with the new satellites which are going to be launched. In fact, there are world over various space agencies. They have planned various airborne monitoring and air monitoring satellites, which we'll be using to augment our existing solution. And there are plans of having constellation of nano satellites. Now you see there is a Planet Labs and these kind of new startups. They can easily implement constellation of LEO satellites using a nano or CubeSats. Plus, there will be advancement in UAV technologies. So which autonomous UAVs which can fly over fracking sites and gather data and come back to the ground station. Plus, there will be advancement in the ground monitoring, like wireless sensor networks, plus there is a technology of IoT, which is Internet of Things. So all this technology will be mature after 2 years, which will be useful in a medium-term plan. Next is a long-term plan. A long-term plan is after 2 years, which is basically based on the future technology. So we believe in a long term, there will be sufficient advancement in space technology, so through which we'll be able to monitor all the fracking sites in detail only from the space. And we will have high spatial resolution as well as high temporal resolution. So let's look at about the roadmap of the various space agencies or their planned these satellites. So if you see the first, we have shown the space, airborne, and ground. Plus, in the short term, we have one satellite, which is one instrument which is called ABI, which is Advanced Baseline Imager. It's basically imaging radiometer operating in geo orbit, and which has a 1 kilometer spatial resolution and less than 1 hour of temporal resolution. There is also one TROPOMI, which is basically tropospheric monitoring instrument, which will be operating, which is an imaging spectrometer operating in LEO orbit, and which has a 7 kilometer resolution, and it has a 1 day of repeativity. So like that, there are various satellite missions which are planned in the near future, which will be usable for this project. Now, if we see the medium-term plan, in medium-term plan, there will be some satellites, like for example, there is a TEMPO, which is basically tropospheric emission monitoring of pollution, which is a geo satellite. And the advantage of geo satellite is the high temporal resolution. Like we can revisit the entire area on 1 hour. So we can have a real-time imaging data. We have real-time information about the air pollution at a national level. So this will be very useful mission for us. Plus there will be advancement in ground as well as airborne UAV technology, which will be used for the medium term. And in the future, which is the long term, in the long term, our main requirement is spatial resolution, which is better than 500 meter, then temporal resolution, which is better than 6 hours, and coverage, which is a national level coverage, and detection of various gases like methane, NOx, ozone, etc. So this is the overall roadmap for implementation of remote sensing system for hydraulic fracturing. Now we'll see how to institutionalize, like how to implement. So like first is the Ohio level. We can implement, like Ohio University can take partnership with EPA, Ohio, for implementation at state level. And OU can also take forward the airborne experiment, like just which was described previously by Fabio and the team. Like whatever airborne spectrometer we have flown, it can be continued for getting more information on various fracking sites. Plus, the EPA will interfaces with various stakeholders at state level and provide the data to various stakeholders. Now the model which has been developed for Ohio, it can be scaled up at national level. The same model can be applied to different states of the USA, and it can be implemented at national level. And the same model can be extended to the global level. The USA model can be replicated by other countries, or that should be, we can have an international cooperation for knowledge sharing as well as data sharing. The data sharing is very important because these different satellites are launched by various countries, and it is very economical if the data from different countries is shared, so that all of the stakeholders have the access to the data, and we can have a very economical solution. So that is the roadmap.
Thank you, Adam and Dr. Himanshu. You've clearly explained what the future needs to look like and why space is so critical to the solution, so thank you.
Thank you.
And now, as we near the end of our show, I want to invite back some guests we had before. So if Dave, our fracking expert, and Marius, our businessman, and then Annie, our Ohio University student, could come back and join us. I'm going to have a quick question and answer panel. Okay, so I have one question for each of you. So Dave, first, can you explain to us why you focus on air pollution as opposed to water pollution or earthquakes?
Sure. So first of all, throughout our research, we had a very limited amount of time and resources. So we really had to focus on something that we could do well. And looking at the water pollution, which seems to be a very big issue, a lot of it has to do with underground water, and that's very hard to monitor from a space-based application. So that one was kind of out for us. And then seismic activity, earthquakes, is another big concern, but there is a large network of infrastructure that's already in place to monitor these problems. So really, we decided to focus on the air side of things. If you go and do a scholarly article search and you type in hydraulic fracturing, you'll find out of 100 articles, almost every single one will be talking about water pollution and earthquakes. And the few that you do find that have air pollution aspects to them are talking about the actual pollutants and not what we can do about it, how we can monitor it. There are a few studies that have been done out there that describe how to monitor it, but they are quick studies that are done and then it is ended. And we're really looking to put forward a model that can be continued and used on a large scale and expanded.
Thank you. And Adam, my next question's for you. Why did you decide to focus on methane as opposed to other air pollutants?
So, as has been explained before, methane is an extremely powerful greenhouse gas, 32 times more potent than a molecule of CO2. So if we care about CO2, and we do, then we should also care about methane. So hydraulic fracturing being such a large source of these emissions, it's absolutely crucial that we know where these emissions are coming from so we can take action against climate change.
Okay, thank you. And Marius, my next question is for you. If you could pass the microphone down, thank you. So as you can see on the screen, the growth in production from natural gas due to fracking has increased in the recent years. How do you weigh this against the environmental costs?
That's a really difficult question. So you all see this graph showing the increase in production of shale gas driven forth by hydraulic fracturing. And that industry creates lots of jobs, not only jobs directly related to drilling the wells and extracting it, but also to the logistics behind services, like you need food, transport, everything. And it's creating lots of jobs. Like, if you're going to try to put this against the environment, right? So you see that the environmental effects can be adverse. You have not only environmental effects, but also have serious health effects, possible environmental effects. So the thing is, what I, like, from a business perspective, I would say fracking is only as good, is better if it's the best option if it's better than the existing solutions. And if you want to be realistic today, the existing solutions are nuclear power, it is coal extraction. And we know that coal emits tons of other pollutants. And fracking has the opportunity to provide possibly greener energy, given that the total greenhouse gases emissions are under a specific level. But do we know that? Do we know that the total emissions are better than those of coal? Do we know that the effects are less adverse than the options, making the best option? No. Without monitoring, there's no way to tell.
Thank you. And Annie, there's been a lot of talk and excitement about this practical airborne experiment that you conducted. Can you explain how you were able to get such good results in just 2 weeks?
Well, like I mentioned previously, we had a really great support structure from the Avionics Center and also the Russ College of Engineering. There was definitely a lot of persistence involved in making it all happen. We also had a really great team of people with different skills and technical expertise. We had experts in remote sensing, experts on the sensor technology. We had lots of communication with the manufacturer, avionics knowledge. I really think it was about bringing the right people together with the can-do attitude of ISU.
Yeah, that makes perfect sense. And Himanshu, my last question is for you. This roadmap that you just presented seems like a fairly expensive endeavor. Can you explain to us how you plan on making it a reality?
Yeah, I think the implementation of this roadmap is very challenging. In fact, I have one surprise announcement for all the entrepreneurs, all the engineers, technocrats, and managers sitting in this room, as well as all over the world watching this event through webcast. We have come up with one competition called SSP Prize X, which is a $30 million competition for implementation of a next generation remote sensing system for monitoring of hydraulic fracturing. So let's see a video. What is this competition?
I'm on board too. SSP Prize X, increase the awesome.
All right, so how about that SSP Prize X? This has been a great panel. Thank you so much for being here. And if any of you are out there in the audience or at home watching are interested in more information about SSP Prize X, you can visit the website you just saw, sspprizex.com. So thanks again for being here. And now, as we wrap up, I just want to say that this has been a very interesting and informative talk show. We've had a variety of guests from all across the board, and we now understand what fracking is, what the problem is, and why space is so critical to the solution. And we also know why we need to focus on air pollution and monitoring its environmental effects from fracking. We've seen the results of a practical airborne experiment in which real remote sensing data was collected and processed for stakeholders to have more information about fracking sites in nearby Ohio. And Dr. Himanshu has presented a roadmap outlining how we can use remote sensing to monitor the atmospheric effects of fracking, not only in the short term, but in the mid and long terms, and just the importance overall of space in this endeavor. So we'd like to thank Ohio University and the Rusk College of Engineering, NASA Glenn Research Center, and NASA Goddard Space Flight Center. And thanks to all of you for watching. We have the information we need to tackle this problem, so let's go make it happen. And we'll see you next time on Space to Earth. Thank you.
Interested to see the depth of work that's gone into this, and just to remind everybody that this is a locally defined TP, and I don't think there's ever been a TP that adhered to that as faithfully as this one has, and so I'd like to express the appreciation of the locals. My question is asking you to discuss the trade-offs. There are these issues. So currently, we don't have a sensor that has the spatial resolution that we need in order to sort of identify individual sites from geo. But I really have a two-part question. Do we have such sensors that could do it possibly from a low Earth orbit? And then Also, have you considered GPS type constellations of coverage as well? Because GEO is the simplest of full coverage, but there are other ways to get that done.
Adam or Dr. Himanshu, do you want to take that?
Yeah, sure. The advantage of geo-based remote sensing is basically revisit time. Like you are continuously looking at the one spot. Like we can immediately we have a coverage of suppose say North America, and we can have a very short revisit time. But disadvantage is the resolution. Like right now also there are some sensors in geo, but they are having a poor spatial resolution. And there have been many missions which are operating on LEO, but again they have a better spatial resolution in terms of some few kilometers. But again, revisit times is in terms of days, like 3 days, that kind of thing. So a future is, I will say that, like for example, the constellation of CubeSats or nanosatellites. Like for example, right now there is, for example, Planet Labs have this constellation for imaging, like in VIS, visual band. But in future, I think there will be constellation for hyperspectral imagers and other spectrometers, imaging spectrometers, so where we can have both higher spatial resolution as well as temporal resolution. So yes, there is a very big promising area for monitoring of air in this field.
But you could get down to a region, and then you could actually, whether you have a full coverage constellation in LEO or not, you might be able to maneuver and then investigate more thoroughly a limited area of whatever country or whatever region you were interested in, and then go down from there. So that's the basic idea, right? You identify sort of a broad regional-based risk, and then you go and look at it from a more local point of view.
Yes, thank you. Very, very good considerations. Let's see, so there's still a lot of confusion about this whole issue. And if you open up any paper and you get different stories, and as you were showing in the scientific reports, even the journal papers contradict themselves. So how would you go about solving that problem to make it, to take all this information and get it out to the public?
Yep. So one of the main things that we focused on when we first got together as a group, we decided that we wanted to keep an unbiased opinion. We don't want to let our previous views or new information that we got about the process distract us and pull us to one side or another. And so our goal was to develop a system that would collect the information and then distribute it out to the public. And so like Adam had presented, he had that GIS software tool, and that was just a small demo of something that we would like to be created to organize all this information together and really inform everybody of the truth. I think a lot of people will hear a news article or somebody's webcast or web page that says things, and from our research we found that a lot of that stuff, you can find no credibility behind it. And so we'd really like to get credible information out so that people can make properly informed decisions.
Great, thank you.
Thank you very much for this emphasis, by the way, because indeed not so many people are looking at the gas side. More people are looking at shift and so on. It also shows that if you have a host like Ohio, that you can do hands-on activities in the SSP in this short time frame. But of course, you need a host who is willing to help you there. There is one point which I still want to contest you about. It's the relation that you're making between cheap fuel and economic revival and so on. Other countries go another way. They don't go for fracking, they don't go for cheap fuel, but they go to reduce the downsizing the motors, getting less consumption. In most of the countries, the consumption of cars has gone down 30% over the last 10 years due to the fact that it's expensive. And then you can go with certain categories which you penalize if they come on the road. And that way, I wonder if that is not another economic model, because at the moment, many people are buying new cars in Europe because they are forced to buy them, because they don't get to the norms anymore. So is your economic model so correct that you say we will win by cheaper fuel, we will have more people, we will more employment? Would there not be another economic model that says forcing the cars to consume less is going to give more employment? I'm challenging you on the question, I know.
So in our report, we were very specific on the idea that we wouldn't make prescriptions for how countries that use fracking, how they should reconstruct their societies to change how they use energy. We just wanted to focus on getting the information out to the people and to the government agencies and to companies so that they could make informed decisions. So I think that what you're proposing is quite interesting. So I think you're sort of getting towards like carbon tax, that kind of idea. That could definitely be a reasonable policy to pursue, but we didn't advocate that specifically for Ohio or for other countries, or other states, I should say.
The motivation presented for monitoring methane gas was largely framed in terms of its consequences as a greenhouse gas. There is at least anecdotal discussion about consequences of methane and possibly other emissions from fracking sites in terms of consequences for health of local populations. For example, if you've seen the film Gaslands, there are examples given of people living near well sites who assert that they're having health problems because of that. I'm wondering if you have any comment on the extent to which current data supports that as an additional concern beyond simply the greenhouse gas. And if that's the case, should that inform the prioritization of how you deploy or focus your remote sensing efforts?
So in our report, we did focus on the health effects and environmental effects. And so you're proposing, I guess, that we go into those areas that we consider priorities and then and do extensive monitoring there. I think that's what you're getting at.
It's a question of whether that is, you think that's an important driver or not.
Mm-hmm. That's an interesting way of doing it. We had in our kind of roadmap, we have a way of prioritizing, at least in the very near term when our monitoring is not so good. So we would use, for example, a satellite to find areas of interest and then hone in using, higher precision, but also obviously more expensive instruments, eventually ground monitoring. So I think that is implied in our discussion, in our report, to do those things.
You have any questions from the audience? For the purposes of the folks listening in.
Hi, Elon Musk here from Solar City. Would you not use solar instead of mining fracking gas?
I didn't understand the question, sorry.
It was an alternative energy question. Why wouldn't you use solar instead of fracking?
Well, I mean, that's a... Yeah, you want to take that?
So one of the things we had said is we really didn't want to focus on changing the energy plan of the U.S. And another thing that I like to say a lot is everybody wants solar energy, everybody wants clean fuels and everything like that, but the infrastructure, everybody wants their air conditioning and they want their lights on too, and you can't just in a day put up a bunch of solar panels. So unless you're really willing to have everybody make that change, then it's very hard to.
And like a side note, the car manufacturers here in Ohio actually trying to transition. They don't want to be dependent on coal. They don't want to be dependent on hydraulic fracturing. So they at the factory they have installed wind turbines providing 10% of the energy they need to produce cars. I think that's Honda in Western Ohio. So.
Hi, I have a question about, you brought in the US EPA, and I'm wondering, the EPA, and it was referred to as, right, we've got clean carbon standards, or, we're shutting down coal plants in Ohio right now. We're going to be shutting down a whole lot more. Is the US EPA an investor to do remote sensing to figure out if they're going to achieve the results around greenhouse gas emissions from those strategies? It seems like they could be a buyer of this strategy immediately to prove globally that they've achieved a major goal over the next 5 to 10 years. You know, fracking is a point in time. Air pollution is very dispersed, broad, and has a lot of sources. We're more impacted in Ohio by Illinois coal plants. So is there an immediate pain point that this technology can solve?
That's actually a really good idea of flipping it around to serve the EPA rather than have the EPA do it. Well, it'd be an interesting area to see private enterprise get involved. If the right incentives, like a Prize X, are created, yeah, that could definitely happen. For example, if they decide to do pricing of pollution, pricing of high pollution from fracking, for example, that could be something that could be done by private enterprise. So I think that I like that idea actually quite a bit.
And just to add to that, we were actually just talking to our TP chair about how the regulations on the EPA right now are, in terms of doing environmental monitoring, are very restricted. Their budget is very restricted to look back on the earth and do this. So I agree. I think that's a very interesting idea if they could potentially buy this data, since maybe they won't be able to do it themselves. So I think you hit on something really important.
All right, and we have time for maybe one more quick question over on this side. Steve.
Steve Brody with ISU. There was an earlier question about low Earth orbit and implementation, and I wonder if the usage as a test bed of the International Space Station came up in a discussion about how to, step up to that point in research.
Does anyone look at that?
It wasn't discussed specifically, but probably most people know that the International Space Station is a really big hub for testing CubeSats. And CubeSat constellations are a big part of our plan in the long term. So I think that it's almost inevitable that we would probably go there when we're testing things, proving them. So I think that makes a lot of sense, actually.
Hi, I'm Kevin Christ, the TP chair for this group, and I just want to say this has been an awesome experience. I want to thank Dennis for putting together to get the hosts for this site, and then being able to pick a project that is local to Ohio. These group of young professionals are phenomenal. The amount of work they have put in over the last 10 weeks, and especially the last 3 weeks has just been amazing. So again, I want to thank everybody. So thank you. One last word. I'd also like to thank Remco, who really, I guess I was more the window dressing, but he's the one that kept this group together, followed them through, and this would not have happened without his diligence through the whole thing. So thank you, Remco.
For TP tracking fracking. Together we take a group picture. Just stay here. We take a group picture. Okay. Yeah. Actually, stay sitting.